Everyone. Welcome back in this Azure well architected framework second video. Not exactly second video, but the second principle, reliability. So today we are going to explore reliability. So the very first question, what it is? Well, the reliability principle in Azure focuses on ensuring that the system is dependable. You can depend on the system to run your workload. It should operate consistently, I mean performance, and recovers gracefully from failures within the accepted downtime or RTO. This involves designing architectures that can handle unexpected disruptions and continue to function effectively. Well, now it makes sense what exactly is the reliability, as the English word means. Whether something is reliable or not, we are applying the same concept on the systems on which our application is running or our workload is running. If something happens, we should rely on that application. If the load goes high in the peak hours, we can rely on those systems on which the application is running. If one of those application breaks, we can rely that our application will not be impacted. You must be aware of chaos or monkey testing, which totally based on this kind of functionality. If something goes wrong, the application would not be affected. Anyways, let's take an example to understand it better. And let's take an example of an online payment gateway, which utilizes Azure availability sets, not zone, but the set, availability set, and ASR, which is Azure Site Recovery. Availability sets will take care of the high availability, and ASR will take care of the disaster recovery, business continuity disaster recovery. In total, we call it BCDR. This setup ensures that in the event of a hardware failure or data center outage, the application remains available, thus maintaining a reliable service for users. Now, you must be picking on data center outage because it's availability set. So within the accepted downtime or RTO, because ASR will help to get the application up and running, right? But if you need reliability over data center outages, you could utilize availability zones. So this is just an example to understand the principle of reliability. I hope it makes sense now. To understand it little deeper, let's dive into the design principles, because ultimately we are referring with these series to the architects. And what they do, they design. How they design? By sticking to the principles. And what are the principles for reliability? These are the principles for the reliability. Let's understand each one of them with some examples and approach. So, design for business requirement, that's our first principle. I always say whatever we are doing, there is a reason behind it. And the very first reason is the business requirement. Now, you're not supposed to just simply go ahead and apply multiple things to make your application or workload reliable. It should align with the business requirement, because creating any other resource will impact the cost, the security, the management, a lot of things going on. It's not just a single resource that you are spinning up to maintain the reliability. Hence, the business requirement is the first priority or first principle you need to set with your stakeholders. You need to understand the business goals. You need to do the proper analysis and then apply the resources for the reliabilities. So the very first is design for business requirement. We gotta align architecture to meet the specific business needs. This principle emphasizes aligning your architecture that you are building for your customer with the specific customer business goals and requirements. So do not just simply go and start applying reliability everywhere. You need to understand the business goals first. It involves the understanding the needs of your organization or your customer's organization. So you need to sit with the customer or the stakeholders. You need to understand uh, what exactly are the requirements for different application, and then apply reliability services for that. Hence, the understanding and integrating business objectives into the architectural design ensures that the solution directly supports business goals, leading to greater effectiveness and user satisfaction. And now it seems like all makes sense. I hope it is clear, and you can start these business requirement analysis, as I was saying, by conducting a thorough analysis of business objectives and identifying the KPIs. Because KPIs are the things which will help you to select the right service so that you are meeting those KPIs. So you gotta design your architecture with business requirement. That's the ultimate point. I have mentioned so many times now, it must be echoing in your head. So let's take an example just to make sure that we understand it properly. Let's suppose you are building an e-commerce website on Azure with the business objective of increasing sales by improving the customer shopping experience in addition to personalizing product recommendation. We have seen those websites, right? So how could you personalize product recommendation? Of course, with Azure machine learning. So you prioritize the reliability aspect as well. So applying machine learning for the recommendation is something that is needed for the user experience, but you need to also take care of the reliability aspect. That's what we are focusing moreover. So we are achieving the business objective as explained, and also the reliability, because reliability ensures that your e-commerce is available 24/7 even during peak times. Downtime can lead to loss of sale or customers. So forget the customer experience. You're losing a customer if the reliability is not in place, and you're missing your revenue. So by designing your application with redundancy and failover mechanisms, you ensure that the website remains operational and responsive, which directly supports the business goal of boosting sales. Furthermore, by implementing monitoring and alerting solutions like Azure Application Insights, you can proactively detect issues and address them. Because you don't want your customer to tell you there is an issue, you want to proactively work on that and fix it. So this means fewer disruptions in the shopping experience, enhancing customer trust and satisfaction, ultimately contributing to increased sales and customer loyalty. So that's how it impacts the entire thing which is running. So business requirement is the must. All right. So our second principle is design for resilience, which is directly means reliability. Resilience. So what it is? So let's understand this first. Resilience is the ability of your system to withstand failures and continue to function. This principle stresses designing your solution to be highly available or fault tolerant and able to recover gracefully from unexpected issues. So you got to create systems that are robust and can handle failures without significant impact. That's what it stands for. Now, how can we build that? There are multiple ways, multiple tools, resources, services available in Azure, right? So there is a reason it comes after business requirement, because once it's analyzed how much resiliency it needs or how much cost we can spend on that particular project, so we can plan for the fault tolerant system or highly available only, then we jump on this part for those mission critical applications. That's why the sequence, you can also think for the sequence, always go with this sequence. You need to understand business requirement first and then apply the resiliency principle. So let's take the approach in this. How can we do that? As I was saying, we got to implement redundancy, failover mechanisms, and auto scaling to ensure that our application can handle increased loads and that failures in one part of the system do not bring down the entire application. SPOF, single point of failure. So in Azure, you might use availability zone, availability sets, or between the regions to distribute your traffic across multiple data centers or zones, as I was saying, to ensure high availability. Additionally, you could use Azure load balancers to evenly distribute traffic, preventing overloads on individual components. So these all are the part of the design. We can consider another example as an healthcare application hosted on Azure that provides real-time monitoring of patient vitals to ensure resiliency, because it is very critical. Somebody's life is on stake. You can design the system to have redundant servers across different regions. In case one region experiences an outage, the application seamlessly fails over to another region, ensuring continuous patient monitoring and minimizing downtime or taking care of any if there is any mishap. All right, so the third principle that we need to understand is recovery. Check the sequence. We understood the business requirement, then we planned for the resiliency. Now, even after the planning something happens, we need to also think for the recovery. If something happens on the resilient architecture, the resilient design, how can we prepare ourselves for this design for the recovery? I hope it makes sense now and you started connecting dots. Well, this principle involves planning for and designing disaster recovery strategies to minimize downtime and data loss in the event of catastrophic failure. It focuses on data backup, disaster recovery testing, and business continuity planning. We gotta we gotta plan for recovery involves backup strategies, disaster recovery planning, and regular drills, which is the most important part of any backup or DR planning drills. Because as they say, you are as prepared as your last successful testing to ensure a quick restoration of services after a disruption. So let's take another example to understand it. A healthcare data management company handles sensitive patient information requiring a robust disaster recovery plan. They implement Azure Site Recovery for their critical workloads, ensuring real-time application to a secondary region. Regular DR drills are conducted to ensure quick and efficient recovery, because you are all familiar with all the steps needed. And in the event of a data center outage, the company can swiftly recover its services, minimizing downtime and ensuring continuity of critical healthcare data management system. Well, it's a wonderful example. Let's take another one to understand the simple solution. Like using Azure, we can set up automated backups of our systems like Azure SQL database to that backup itself can be geo-redundant or on the geo-redundant storage, which ensures that your data is safe and can be restored in case of failure, right? So that's the recovery. You got to plan for the recovery. No, we cannot neglect the operations. So you got to design for the operations as well, thinking operations in mind as well. You got to ensure smooth and efficient day-to-day operations. So designing with operations in mind, including monitoring, alerting, and automation, leads to easier management and quicker resolution of issues. Everything is connected to the reliability. You should be aware what is happening. Implement Azure DevOps practices, use Azure Monitor for real-time monitoring and alerts, and create scripts and automation for provisioning and managing resources. So that's what the operations are, and that's how we can plan for it. To understand it better, let's take an example of a mobile gaming company which needs to manage a fleet of gaming servers with minimal operational overhead. And why minimal operational overhead? Because you also need to maintain the other pillars, right? Operational efficiency and operational excellence and performance efficiency as well. And less human interaction means less scope of error. So the company uses AKS for container orchestration along with Azure Monitor and Azure Automation for real-time monitoring and automatic scaling based on the user demand. So this setup allows for streamlined management of server resources, automated scaling during peak gaming hours, and proactive handling of operational issues, leading to an optimized operational workflow. So it's a good example. Let's take another one. In a data intensive analytics project hosted on Azure, you can implement ADA for Azure Data Factory to automate data ingestion, transformation, and loading process. This reduces the operational overhead of manual data handling, enhances efficiency, and simplifies the management of data workflows, aligning with the principle of designing for operations. Now, why are we automating? If you're leaving it on a human being, maybe he forget to do it, maybe he don't know where the script is, maybe he doesn't have the access to the on-prem, or anything can happen. But if you're automating it, you're making it more reliable. And we don't want to complicate things on the name of automation, on the name of reliability, on the name of multiple resources and everything. At the end, you want to make it simple. You want to keep it simple because simple is good. Simple is something which is relatable. So avoid unnecessary complexity in your design. This principle advises against the overcomplicating your architecture. It suggests that simpler solutions are often easier to manage, troubleshoot, and scale. Simplicity in design helps in easier management, lower cost, and often greater reliability. It involves choosing straightforward solutions that meet requirements without overcomplicating the architecture. Focus on using Azure services and features that align with your requirements. Instead of building a custom authentication system, you can leverage Azure Active Directory for user authentication in your application, which simplifies the authentication process and integrates seamless with the Azure services. Just a thought for simplicity and not overcomplicating the architecture. We can take an example. A small business wants to host its first website without incurring high infrastructure cost or complexity. The business opts for Azure App Service to host its website, benefiting from managed platform that abstracts away the underlying infrastructure complexities. The solution includes integrated Azure SQL database for data storage, again, of course, PaaS services. This straightforward approach allows the business to focus on developing its website content and functionality without worrying about the complex cloud configurations. The simplicity of Azure App Service reduces both cost and the need for specialized cloud management skills. So each of these principles plays a crucial role in ensuring the reliability and effectiveness of Azure-based solutions, aligning closely with specific business needs and operational requirements. I hope these design principles make more sense now. So let's do the trade-offs now, because when you design, you don't design only for the reliability, there are other principles as well that we covered in the previous videos. So let's trade off with other pillars like security, cost, operation, and performance. Let's take an example with the security first. Implementing extensive uh, replication for reliability increases the workload surface area for potentially exposing for threats, potentially exposing more areas to security vulnerabilities. So, what can we do? Well, this is the trade off. We need to understand, do we want the replication or we want both, or how can we achieve the business requirement with one of those pillars or maybe both of them? Let's take an example. A cloud-based file storage service uses multiple data replicas across regions for reliability. While this ensures data availability in case of regional outages, it also increases the number of endpoints that need to be secured, raising the complexity of the security model. So, whenever you are going, as I was saying at the very beginning, about when we work for the reliability, it also impacts the other stuff as well. For example, security and the management in this case. All right, so do not just simply create stuff for the reliability, enable replication for the reliability, also think for the security, right? And if your business demands, only then you go ahead for those particular workloads. Now, trade off with the cost. Achieving high reliability often involves over provisioning resources, leading to increased cost. We all know that. Well, an online streaming service maintains additional server capacity to handle peak loads, ensures reliable streaming during high demand events. Our second trade off is with cost. Achieving higher reliability often involves over provisioning resources. We all know that, which ultimately leading to increased cost. Let's try to understand this with an example. Let's suppose an online streaming service maintains additional server capacity to handle peak loads, ensuring reliable streaming during high demand events. This over-provisioning, while beneficial for reliability, results in underutilized resources during off-peak times, increasing operational cost. And let's see how it is connected with the operational excellence. Enhancing reliability can add operational complexity, requiring more sophisticated management and monitoring. We can understand this by another example of a multinational corporation uses a complex network of distributed databases to ensure reliable data access. While this enhances reliability, it also complicates database management and requires a more skilled operational team to maintain optimal performance. So, the idea is, let's cover this performance one as well, and then we'll conclude. Implementing reliability measures like data replication or geo distribution can introduce latency, impacting performance. Uh, let's take an example to make a point. Let's suppose a financial services company uses geographical distributed servers to ensure reliability. While this setup protects against regional failures, it also introduces network latency affecting the speed of transactions. In summary, while aiming for high availability in Azure architecture, it's important to consider how it might affect other areas like security, cost, operations, and performance. Balancing these trade-offs involves careful planning and a clear understanding of business priorities and technical requirements. So the idea behind these trade-offs here in this particular video to understand how actions for reliability impacts the other pillars. But the actual trade-off is all about careful planning and a clear understanding of business objectives. And of course, technical requirements. So with this, we understand how this is connected with the other aspects of well-architected framework. Now we know the design principles. We understood it properly. Now we also know how it is connected to the other uh, aspects of WAF. Now it's time to create a checklist. Well, what is the checklist? Well, after applying all those reliability stuff in your architecture, this is simply a checklist that will help you understand if everything is in place, or if not, what are those things. Maybe you have a justified reason behind that, but you should be aware. So the very first is align with business objectives that I always make a point or emphasize on. So design your workload to meet business goals with avoiding unnecessary complexity. The second one is conduct failure mode analysis, FMA. You got to use this analysis to identify and prioritize potential failures and their impacts. Let's take an example of analyzing a cloud-based CRM system or CRM's components to understand how each failure could affect customer data access and developing strategies to mitigate these risks. So FMA will help you understand your architecture and the potential failures, and of course, their impacts. The third point is define reliability and recovery targets. You got to set clear targets for reliability and recovery for all components and the overall solution that usually come from the business. Your RTOs, RPOs, and SLAs. Setting specific uptime targets for a cloud-hosted video streaming service and defining clear recovery steps in case of outage will cover this point all in a holistic way. Then if you have something like that, then of course check that box. Then you got to implement the redundancy. If you have implemented for all the components and resources, check that box, like add redundancy at different levels. That's what I mean by the different components, especially for your mission critical application or vital processes. If you have planned for those, check that box. Now, scaling strategy. Well, scaling, of course, helps reliability. So develop a scaling strategy that responds efficiently to varying loads. If load changes, the number of VMs changes, number of pods changes. We understand the scalability, horizontal scalability. And if the load increases, number of VMs increases to balance that load. So it makes the system reliable. So you should have that kind of strategies in place for your mission critical applications or the application that demands scalability as per your business objectives. If you have something like that in place for your workloads, check that box, and then strengthen resiliency and recoverability. You gotta integrate self-preservation and self-healing measures. That's what it means, strengthening it by self-healing measures. For example, building a retail website with automatic failover mechanisms that switch traffic to backup system in case of a primary system failure. check that box. If not, then think about it and then go with point number 7. Test for resilience and availability. We talked in the design principle. It's as good as you last tested. So apply chaos engineering principles to validate system robustness, of course, after testing. Chaos is more like you are checking how robust your system is, right? But testing your resiliency is something different. You're not breaking your application, you're testing how early you can recover. Chaos could be fall under this point. So that's why I gave that example. Then uh, next point in the checklist is BCDR plans. Do you have those in place? If not, you got to develop a comprehensive BCDR plans and check that box. You need to measure and publish health indicators, means monitoring. You need to continuously monitor and report on the health and reliability of the solution. If you have proper monitoring of all the components and everything in place, check that box. Well, with this checklist, you can easily go through your design from the reliability perspective. Try to check the box. You need not to check all the box, but as per the business requirement for that particular workload, you need to select. Nothing is missed. Now, just to conclude this video, because this is the end, I would like to add few tools and services that helps achieving the redundancy like availability zone, load balancer, traffic manager, Azure backup, Azure site recovery, Azure monitor, application insight, right? Auto scaling in VMSs or AKS. AKS, even pods running on the VMs could be auto scaled, even the pods can be auto scaled. Your app service has the auto scaling in place, highly available architecture. If you think your VMSs on the availability zones, your AKS on the zones, so there are multiple things, tools, resources, services available in Azure, but it doesn't make your architecture and your design reliable. You should be aware of all those services. Then you should be aware how to implement and when to utilize those services and make your solution more reliable. Thank you for watching, and you guys have a wonderful day. Take care. Bye bye.